Alright, so hi, I'm back. So for this video, we're going to talk about lesson 2, understanding z-scores. So be sure that if you're watching this video or you are answering module 2 lesson 2, z-table should be on your side always. So this is the z-table. I attach it in your module, this z-table. We have two sides, the negative sides and the positive sides. And remember that uh, the total area of this z-score or z-table is 1. Okay, and the direction of this one is from left to right, right? So it is from left to right. Do not forget from left to right. So will be discussing you this one because there are some, like this activity, there are some that are wrong. I was not able to check it before distributing it to you, but I'm going to check it now for our discussion. Okay, so our competency is identify regions under normal curve corresponding to different standard normal values. So at the end of the lesson, you should be able to use the z-table. This is what I'm referring to. And sketch the normal curve showing the required area. So let's going to make use of this example here in your activity. So I'm going to draw it on the other side so that I can make use of the table. So let's have activity number 1. So suppose alright, suppose that is a straight line with a normal curve. Oh my god, that is not a triangle. Let's have another one. How could you? Should be a straight line. So number 1, so we have here a straight line, and then you have here a normal curve like that. Alright, so again, we don't have the mean, so that is simply 0, 1, 2, 3, and then same thing as negative 1, negative 2, negative 3. Alright, so suppose now your z is equals to 1. So we have here the z is equals to 1. We are looking for the value of this side. We are looking the area of this shaded region. Again, do not mind the the number here in the module. Do not mind this one. Not mind. I'm going to explain it here. So say for example, you are given the z is equals to 1, and then you are going to look for this shaded region. So we need to look for the area of this one. Again, before we're going to make use of this, I'm going to explain this to you. This line here, this column here, you're talking about the z. Yes, we have negative 3.4. So if you are given like negative 3.43, then you go to negative 3.4, and then this 3, you look for this one. 1, 2, 3. So this one. So you get the where they intersect. So this one. So the area of this negative 3.43 is 0.0003. Alright? Okay? So this time we are given here z is equals to 1. So therefore we are looking for positive 1. Positive 1. Where is positive 1? You look in your table, positive 1. So positive 1 is here. Yes. Positive 1. 1.0. So this one. So we are not going to make use of 1.1 because that is not 1.0, only 1. So that is 1. So this is what we are looking for. So the area of this one is 0.8413. Alright, remember z, the area of this z is negative 0.8413. Again, z is equals to 1. That is the area 0.8413. So remember that we are looking this region. Remember I told you the region, the area is from left to right. So from left to, let's use red. So it is from left to right. So therefore, if I'm going to graph this negative 84.13, this negative 84.13 is from left to right. This is the area. Yes, this is the area of your 0.84 13. This is the area because it is from left to right. But we need to look for this area man the other side. So how are we going to get the area of z that is greater than z? Okay, so that is z. Yes, z. So how are we going to look for that one? By, remember, the total sum, the sum of the area of the z is 1. So in order for us to get this area here, the black region, this black region, we need to subtract this one from the whole. So therefore, remember, because our whole or the totality is 1, so we can have 1 minus 0.8413. Can you get it? Huh? Can you get it? So that is 1.8413. So if we're going to subtract that 1, what is the answer? So that is 1 minus 0.8413. That is 0.1587. Again, the answer for this one is, the answer for this one is 1587. So this 0.187, that is the area here. Can you get it? If you have question, you can just comment. Can you get it? Again, because we are looking here, this area, that's why we did the subtraction. Why? Because the given here, the given z-score here is from left to right. So we cannot use this 8.8413 as this area here because it is from the area from left to right. It is on the other side, which is this red color. That's why in order for us to get the black region or this region, we need to subtract it from the whole or the totality. So that's why we have 1 minus the z-score, which is the equivalent to 1, that is 0.5. So that is the area of this. So this is the area of 0.1587. So this is the area of this black region. Can you get it? Questions? And if you have questions, you can just comment down below for me to answer your queries. Okay? Let's have another example. Let's have another example. How about number 2? See? The same thing. We are looking for the shaded region violet here, diba? We are looking for this shaded region. So therefore, what are we going to do? We are going to get the value of this negative 2.2, because this negative 2.2, this is the value here, this small one. Remember, because it is from left to right. But we need this one. We need this region. So by this, you get the value for this one using the z table, negative 2.52. So this is positive. Be careful. Negative, we are using negative. So again, what was the given? Negative 2.52. So we are looking for negative 2.52. So negative 2.5, yes, negative 2.5, and then 52 man. So we have 2. So we have here, alright. So we have, that is equivalent to 0.0059. So go back to our module. That's correct. That's why we subtracted 1 here. Okay? So 1, again, this one here means the totality of the area, this one here, minus this 2.2, this is the value of negative 2.52. So if you look for the answer for that one, that is 1 minus 0.0059, that is 0.9941. So this 9941, this is the area, the shaded region. So this is 0.9941. This area here is the 9941. So clue there, if the shaded area is on the right side, not on the left side, yes, on this area. So example, this is the normal curve. Yes, and if this is the shaded area here, therefore you already know that you are going to get the z-score, subtract the z-score by 1. Okay, remember this one. If it's on the area, it's on the right area, you need it subtracted by 1. So get the z-score, not this one. You're not going to subtract negative 2.52. It should be the area of negative 2.52. Okay, because it will not get the correct answer. Again, it should be the area of this negative 2.52. Okay, are we clear? Let's have another example. Let's have another example for this one. Let's have number 3. Yes, number 3. Okay, so we have here given, say for example, between. This term here is what we call between. And this one here is greater than. Yes, greater than. I will explain that one to you later on. Greater than, this is between. Yes, between. This is if we're going to make this one into mathematical sentence, yes, if we're going to have this one into mathematical sentence, we have x is greater than negative 1.25 but lesser than, what's this, is lesser than 2.45. By the way, we're not going to use x because we're going to use z. Yes, z. So we're going to use z here. Okay, that is between. Okay, so again, we need to look for the area of this one, and we need to look also the area of this one. You can imagine if you can have this one, if this is the format. So we have between, meaning we have the limitation, right? Okay, so look for positive 1.25 in your z table, positive 1.25. So 1.2, yes, 1.2, 1.2 here, and then 5. So 1.2, 1.2. Please do not make use of this one. Okay, you only have one copy. If you're going to write like this one, then it will be bumot. So this one. So you have the value 89.8944. So 0.8944. So that's how you get this value. Just look for the value of this one. Okay, then look for 2.45. Let's not follow the module because it is shortcut. If I'm going to follow that one, you will be asking me more. So that's why I'm explaining this to you, how to get these numbers here. So again, look for 2.45, positive 2.45. So 2.4, this is 0. Yes, this is 0. This is 1, 2, 3, 4, 5. So this is 5. Am I correct? Yes, 5. Yeah. There you go. So 5. 0.9929. So 0.9929. So can you get it? Okay. So in order for us to solve this one, of course, we need to make use of the larger value. Yes, larger value, and subtract by the smaller value to get this shaded region. So by this, we have atong baliktaron. So we have 9.9929 minus 0.8944. So that is equals to 9929.9929 minus 8944. Joke. It should be decimal places. So the answer is 0.985. So 0, yes. So this shaded area here, that is 0.0985. Okay, are we clear? The same procedure that you're going to have this one. You need to get first the area of this one, area of this one. The same thing as area and area. because again, it is the direction for this one is from left to right. Okay, from left to right. So if you are going to get the area of this one, this is the given area is from this up to left to right, this one to this one. Yeah, and the same thing as like that. This here is from this shaded part. Yan. No, lumalapas tayo. Wait, why did we subtract this one? Because this 0.58 is from left to right. We have this the value. So this is the area of 0.58. And this one here, this is the value of negative 1.116. That's why we subtracted the area of 0.58 from the area of negative 1 point. So nabali siya because this is larger. The area of 0.58 is larger than negative 1.16. The same thing as here. From left to right, this is the value of 1.25. And this one here is the value here. The value of 2.45. That's why we subtract the area of 1.25 from the area of 2.45. The same thing as here, from left to right, this is negative 2, and from left to right again, this is negative 1. So you get the area for this one and the area of negative 1, then you subtract. Okay, so that is the process of between. Okay, so by this is the example. We already know this one, so this is further another examples. You can do that one, by the way, but I am already done explaining this to you how to get this one. Just keep on practicing for you to easily find the value. Okay, so steps, and then never mind the steps, just follow what it taught you, because it's easier for you to remember. So again, to cope up with, I'm going to give you another example for summarization. So say for example here, if you have here the value, say for example this is 0, and then you need to look for negative 1.75, and this is the area that you need to get. This is the area that you need to get. Just follow the solution for this one, which is so z is equals to so z is equals to negative 1.75, which is equals to negative 1.75 here. Our table, negative 1.75. 0, 1, 2, 3, 4, 5. That is, why did we automatically answer 0.041? Because it is already given from left to right. Kuha. Why did we answer that automatically? Because it is from left to right. I'm going to give you another example. These are the second example. Suppose I'm going to have this again, another set of symmetric or normal distribution. Then I'm going to look for this is 0. I'm going to look for 0.95, this area here. Yes, this is the area. This is the area. So if I'm going to answer that one, you have here z is greater than 0.95. Why greater than? But this one, this is less than. Z is less than negative 1.75. Yes. Less than because here, pagamay, di ba? Lesser, negative numbers. Okay, so that is the answer. I think it's not 040. 04. I lack 0 here. Alright. So this one, this time, this is greater than because it is greater than 05. It's going to the left. Alright, let's go into the right. That's why, again, how to solve this one, you need to get the value for this one. So that is 1 minus, that's why we have 1 here because it's the totality of the area minus this one, which is 0.95. Positive 0.95. Yes. Positive 0.95 here. So that is 0.8289. So that is 1 minus 0.8289. So that is 0.1711. So again, this 0.711, this is the area. So this is 0.1711. Remember this negative 829, this negative 829, this is from left to right. This is 0.95, the area, which is 0.8289. So this is the area covered from that one. That's why we subtracted 1, because it is greater than. Then the next one, the next example is number 3, which is the previous example, which is number between. Yes, suppose we have here a normal curve and we are going to get the value of this is here. We need to get the value of 1 and negative 0.5. Yes, we need to get the value between 0.5 to 1. So again, that's what I have discussed to you. You have z is greater than negative 0.5 but lesser than 1, which is equals to, how to answer this one? By getting the area of 1, which is 1 here, area of 1. So if you're going to have here, so this is 1, which is 0.8413 minus 0.8413 minus negative 0.5. Negative 0.5 is here. So 0.3085. So 84.8413 minus 0.385. So the answer is 0.5328. So this is the area. So this is 0.5328. Again, remember, why did we subtract? Because from left to right, this one, this is the area of 0.5, and this area is from 1. So that's why we subtract the area of 1, which is, what's this? 1 is 0.8413 and 0.5 is 0.3085. Okay, so I hope it's clear to you the 3 different types. We have the less than, the greater than, and between. So less than, the greater than, and between. You can easily get what to solve if you have this illustration. So that's why you need to draw for you to answer, because you need to practice more before you finally easy for you to answer. So that's all about lesson 2, sketching a normal curve. using the Z table. So I hope you learned something from today's video, and I will be back for lesson 3. If more questions, just PM me or comment down below. Thank you and God bless.